Welcome to today's webinar, Containers in Production, Real-World Solutions for Networking, Security, and Storage. My name is Kate Lehman. I am the Head of Communications at Big Switch, and I will be your host for today's webinar. Joining us is Gu Rao, Portworks Chief Technology Officer, Rainey Osnat, Vice President of Product Marketing at Aqua Security, and Bala Ramachandran, our Director of Product Management. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you are watching this video in a rebroadcast or a recording, or have questions on an upcoming webinar topic that you would like our panelists to address, email us at info@bigswitch.com. We have also provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard. We have a full agenda for today's webinar. Let's get started. To get things started today, we wanted to launch a poll so we can understand how you are using containers today. Please take a minute to answer the question and we will share the results with you. Gartner predicts that by 2020, more than 50% of global organizations will be running containerized applications in production, up from less than 20% as of October 2017. At Big Switch, we already have several customers running applications in production, and I would say nearly all have stated they plan to use or are beginning to use in development environments. What has been somewhat surprising to us is the number of customers who already have deployed containers in production. We expected it to happen at a slower rate. Gu, Rainey, are you experiencing the same with your customers?
Yep, we are definitely experiencing customers moving applications containerized into production at a much faster rate than we had anticipated.
Yeah, we see the same, and I would expect people on this webinar to split unevenly between these four answers, with probably a larger chunk around the two kind of intermediate stages of using containers in development and having a few applications in production. And there's probably a few that already have many applications in productions and a few that are just starting out.
Bala, what do you think the results are going to show?
I think it's definitely a huge trend, and I think it is the containers in development stages make sense, and people are definitely starting to think about it, and they're starting to plan it out to start with. So I think while some of them might have already started in production, there'll be a lot more in the planning stage, is what I think.
Let's take a look at the results. So 64% of you said you're just starting out or planning to use containers. 18% of you are using containers in development only. 12% have a few applications in production, and 6% of you have many applications in production. So I think that aligns with kind of what we're all seeing across the board.
Hopefully we can all help a lot more people move to production.
Yeah, that's the goal of today, to get you guys into production.
Absolutely.
Okay. Infrastructure and operations teams are under increasing pressure to deliver applications more quickly to support digital business. Using containers can help enterprises modernize legacy applications and create new cloud-native applications that are both scalable and agile. But containers are not without their challenges. As organizations start to deploy larger volumes of containers, key challenges need to be accounted for. In December 2017, the Cloud Native Computing Foundation conducted a survey of its community to learn more about the current landscape of cloud-native technologies. More than 550 community members responded to this survey. In the survey, respondents were asked to rank the top challenges they are facing when deploying containers. Networking, security, and storage were the three highest ranking challenges. With the CNCF survey results in mind, today's webinar will address networking, storage, and security solutions and strategy. These are also three of the 6 key elements that Gartner identifies should be driving your container platform strategy. Gu will begin today's webinar with an overview of Portworx and its cloud-native storage solutions for containers. Following Gu's overview, we will hear from Rainey, who will provide an overview of Aqua's solution and explain why it is ideal for containerized environments. Next, we will hear from Bala, who will provide an overview of Big Cloud Fabric, the leading cloud-native networking solution for containers.
Thank you very much for having me. What we're seeing happening in the modern enterprise is the need for the software deployment infrastructure admins to embrace agility in how they deploy their software. So there's been a change in how modern enterprise software itself is architected, right? So it's not monolithic anymore. It's not such that your business logic, your GUI, your storage, it can all be packaged in one monolithic VM and deployed as such. Inherently, modern software is distributed, and alongside with this, people want to have a more agile way to deploy these applications and iterate quickly. So in order to facilitate this, what we're seeing happening in how enterprise software architectures are deployed is a shift from, the traditional fixed way of, managing your IT, where there's a separate IT department that is responsible for storage or servers or networking, and they provision the required hardware, and then the application owners come in and deploy their applications on top of that. That's sort of rapidly shifting to a more agile stack, which is kind of what I'm trying to show here on the right-hand side, largely driven by minimal OS, but where these modern applications, which are distributed, are packaged as containers and deployed by a cloud-native software orchestrator, such as Kubernetes, for example. And in this new stack, you have a need for a new architecture for all three things that we're going to talk about today: storage, networking, and security. So where Portworx comes in is our goal is to allow you to deploy stateful applications that require storage via these modern container orchestrators such as Kubernetes, where your applications are packaged as containers. Portworx is a software-defined storage solution purpose-built to provision stateful services storage to your containers. What we do is we provision block and file, container granular volumes, all of these which are orchestrated by a cloud-native scheduler such as Kubernetes. When Portworx first starts, the first thing that it does is it fingerprints your hardware environment. It takes a look at the different type of storage resources your servers have, if it's running on-prem, or if it's running in cloud, it takes a look at the various cloud volumes that may be available. For example, if you're running in AWS, it can detect different EBS type volume types, whether it's provision IOPS, GP2, instance local store. If it's running on-prem, it detects for the presence of spinning drives versus SSDs versus flash. From here, what Portworx does is it carves out a big pool of storage from which it derives container granular volumes. All of these are provisioned at the request of your application, your end users, your DevOps admins that are deploying these applications. Programmatically, they would specify via Kubernetes. Taking a look at this example, there's a sample stack of Nginx container talking to Python, talking to MySQL. In this example, if MySQL said it wants, a few gigabytes of high IOPS storage with encryption, with high availability, it's Portworx's responsibility to make that available to that container. All of this is done in conjunction by talking to Kubernetes. Portworx itself is just another container. It is deployed and managed by your container orchestrator. If you're running Kubernetes, you would just do kubectl apply Portworx. Kubernetes would go in and install Portworx pervasively on every node in your environment. And from there, it really is just a hands-free usability experience. The main benefits that Portworx provides in a Kubernetes or a container orchestrated environment is it really gives the controls back to DevOps. So there is no out-of-band storage provisioning anymore. Your end users can simply provision or allocate or deploy their applications directly through Kubernetes and consume any of the storage resources they want. Using this, what we're seeing is all of modern enterprises quickly rolling out and building a platform or the next generation database or a container as a service platform, leveraging these tools. And it really is to provide their end users with that cloud native experience, right? So using technologies like Kubernetes and Big Switch and some of the other solutions we're going to talk about today, you are now able to build a cloud agnostic platform stack from which your end users can very quickly deploy any kind of applications they want, make changes they want, consume all of the resources programmatically without involving out-of-band IT provisioning. Portworx itself, in addition to being container granular, is application aware. Your application is not just any one container, right? It's typically a stack of containers. It is topology aware, so if you're deploying a complex application, for example, like Cassandra, Portworx will make sure that the data blocks are scheduled on servers that are not in the same failure domain, for example. All of your operations can be done at container granularity. What that means is you can have different set of volume properties for Cassandra and a completely different set of volume properties in this example, for example, for Postgres. So you're not tied to making global system level decisions as you would with a traditional storage solution. So I'll quickly describe how all of this works and show a couple of use cases. At the core, as I mentioned, is the Portworx software-defined storage solution, which is provisioning storage. It has three components. Stork is its integration with Kubernetes. On the right-hand side, you see a component where it is communicating constantly with the cloud platform providers, or if you're running on-prem, constantly monitoring your storage drives. The reality is, when it comes to storage, there's durability issues. If everything were stateless or ephemeral, things are easy, right? But with storage, things have a lifespan beyond when the container lives. So Portworx is monitoring the degradation of the drives, the health of the system, and using that information to not only communicate back to your monitoring software, such as Prometheus, Sysdig, or Datadog, to name a few, but also to influence Kubernetes to reschedule the pod to a different system if storage is misbehaving. So all of that is taken care of and automated, so you don't have to worry about it. As I mentioned at the beginning of the presentation, we are seeing a large number of customers move stateful applications into production, and I want to talk a little bit about some of the top use cases we see. By far, most of our customers are using Kubernetes and Portworx and these other technologies to build out the next generation platform as a service. The goal here is really to empower their end users to deploy any application they want using the Kubernetes user experience to get that cloud native way of deploying applications. We're also seeing a large number of Jenkins as a service being rolled out, in addition to people just building out a general purpose PaaS or a database as a service. Jenkins is an example of many type of other applications that are sort of full stack applications. We see WordPress fall in this category too. We have a large number of WordPress hosting customers that use, again, Kubernetes and Portworx to put together a WordPress hosted service. Finally, I just want to touch on a new case study that we just did with NIO. NIO basically it's the next generation autonomous vehicle company. If you haven't heard of NIO, please check out NIO. Go to nio.com. They're doing some very cool stuff with self-driving cars and how they use Kubernetes and actually in their case DCOS as well, to empower their end users and scientists to quickly iterate over the type of applications they're putting together, where they're really going through large chunks of data, doing a lot of scientific computation, and moving data and applications around between across clouds actually. Just quickly go through their use case, where data comes in off of the car and sits in a data lake. From there, the data is siphoned off into a queue where, so it's first sent to Kafka, and so all of these are, everything that I'm showing here are running as containers, from where the messages are processed, worked on, and then the resulting data is then sent to Cassandra database. They have some post-processing that happens with in Elk. The primary tier is driven by Mesosphere as the container orchestrator. The data is obviously in both cases stored on Portworx. And Portworx, in addition to managing the state for the Kafka, Cassandra, and Elasticsearch instances, will also facilitate the movement of the data between the Mesosphere and the Kubernetes cluster. The Kubernetes cluster has a different set of use cases where there's some post-processing that's done on the results of this data, which happen to run in Java containers, which talk to a Postgres database. The real thing about Neo adopting Portworx and Kubernetes was it's all about agility. Their alternatives were to do things using virtual machines and fixed servers. And the cycle time around which the scientists could iterate with their applications and changes to their application infrastructure were too high. They need to move fast. It's a highly competitive space that Neo is in. And so this really got their productivity level to where it needs to be. Also want to emphasize here that many of you are probably thinking about not just cross-site use cases, but also perhaps cross-cloud or hybrid cloud use cases. We've been talking about this as an industry for quite some time, but it's here. Hybrid cloud is possible today. It is being done. We have a large number of customers that are able to straddle their data centers between their private cloud to public cloud, or across public clouds, or even within the same public cloud across different availability zones, right? And so, for example, if you're running in AWS, you would want to run your applications between different availability zones within AWS. So all of this is possible now with container orchestrators like Kubernetes or Mesosphere, and intelligent storage technologies like Portworx, which allow for or facilitate the movement of the state associated with the containers. So I encourage you to check out more about what Portworx is doing. You could go to portworx.com. That's portworx.com. There's a lot of information also on our doc site, which is docs.portworx.com. And also, you can go to our blog site, portworx.com/blogs, where you actually will hear directly from end users, architects that have put together solutions using Portworx or Kubernetes or Mesosphere, and learn, the lessons that they've learned, challenges that they've had to go through. Thank you.
Good. Thank you for telling us about Portworx and your cloud-native storage solution for containers. We did have a question come in when you were going through your slides. The question is, does Portworx run in the container itself? If you can address that briefly.
Yes, the answer is yes. Portworx does run inside of a container, and Portworx is typically deployed and managed by the container orchestrator. So, for example, when running in a Kubernetes environment, it deploys as a daemon set, and so Kubernetes would deploy the Portworx containers on all your systems.
Great, thanks. And Gartner named Portworx last year as a cool vendor in storage technologies. At the end of this slide, there is a link to access that report. Next up, we're going to go to Ronnie Osnat, VP of Product Marketing at Aqua Security, who's going to tell us about their ideal security solution for containers.
Thanks, Kate. Hi, everyone. Yeah, we're going to talk about security now. There are a lot of similarities between what you just described and the cloud environments that we work in. And if we look at the shift that containers and other things that go along with containers, typically like microservices and DevOps processes, due to security, then we see a really dramatic shift, right? We have a change not just in the stack, which is very similar to what Gu described, but also in the development cycles that are much more rapid. And so when you look at traditional security tools, they're really not equipped to handle that speed of deployment. We have customers who update their images, thousands of times per week. And this is not something that traditional security tools can handle. And so you have to have something that kind of moves along with the process, covers it from the beginning all the way to production. and can also obviously operate within that stack of orchestration, container engines running on different types of machines in the cloud, and so forth, as well as solve the networking or network security issue, rather, not networking, the network security issue, which is that containers also behave, they have their own way of communicating in a network, which is not like traditional networks that are more static or between VMs that are easier to spot. So that's something that we see as the main challenge in this space. We actually conducted a survey late last year and asked around 500 respondents who are in this space what they see as their main challenges or areas to focus on regarding security. And as you can see, there's number one and number two are very closely related to DevOps processes, basically the ability to detect vulnerabilities that are introduced into your code, and managing secrets, which are those passwords, tokens, and other sensitive information that you need to have, you need containers to access. And this is something that is not easy to do in the container space because you don't want to expose those secrets to anything else but the container that needs it. And then there are things around managing the pipeline, like enforcing the use of approved images, isolating containers when they run on the host, and then of course runtime visibility and the segmentation or firewalling of the containers in their network environment. So what Aqua does, our approach is to provide a full lifecycle security solution, meaning we start from the very early stages of when you build your container images. We integrate into the CI/CD pipeline and do what's known in the industry as shifting left of security. The reason here is that if you wait to slap on security as an afterthought after the container is already running, you're probably not going to be able to handle the level and scope of vulnerabilities and what we call attack surface, the ability to attack your application from various directions in an effective way. So you really have to secure the application as it's being developed and as it's being pushed through the pipeline. We then really work on securing the runtime to enforce the use of only trusted images, ensure they're properly configured, ensure that immutability is enforced, right? So the notion that when you have a running container, nobody is supposed to touch it, right? It's supposed to be running. The orchestrator, like Kubernetes, is what's running it. And if you need to update your application, you basically create an updated image and you push that through the orchestrator to replace the old containers. There's no patching, right, of containers as they're running. And then the network aspect, which has to do with visualization, visibility, as well as creating firewall rules to determine which containers can talk to which other containers or other external systems. So how do we do this? I'll go quickly through basically the basic features of our platform. I'll just say that, like Portworx, we also deploy as a container. All of our components are containers, and typically for the runtime enforcement, you would deploy us using daemon sets and Kubernetes or other orchestrators. So we start with CI/CD. CI/CD, these are the environments where developers work, where they create their applications, their image. And what we do is we integrate with those tools to provide developers the ability to understand what the security posture of their code is before it's delivered. So they will see within their environment, they don't need to use our software for this. Well, they are using it, but within their environment. In a familiar user interface, whether it's Jenkins or Bamboo or any of the other tools that are widely used in this environment. And this will tell them what vulnerabilities they have, if they have any embedded secrets, configuration issues, malware, etc., so that they can fix it before it's being delivered. And this basically avoids the conflict later of security teams saying, hey, this code is vulnerable, you can't run it. At the next stage, we also monitor the registries. Registries are where images are stored. Typically, organizations will have at least 2 registries, one for development and another one which is the production ready or staging registry. And what we do there is continuously scan the images to make sure that they don't contain any vulnerabilities, secrets, etc. Very similar to what we did in the CI/CD pipeline. The reason we do it again here is because you may have built an image that was okay when it was built. It was scanned, it was fine. 3 days passed, it's stored in the registry, and now this new vulnerability was discovered that affects your image. You want to know that, and this is why we do this. We also correlate from multiple sources, and we update this database on a daily basis. So you're always up to date in terms of the latest vulnerability posture. The next stage is really determining which images you can run. And here we use risk policies that take into account the various, the information that we gathered in the earlier stages. And according to your policy, whether it's a blacklisting of vulnerabilities or of types of open source software licenses, the severity of the vulnerabilities, malware, etc. According to that, you can create your own policy, and we will either allow or disallow, prevent the image from running. We also uniquely identify the image to make sure we can track it throughout this entire pipeline. So if anyone tries to spoof an image or tries to run an image that did not go through this process, they will not be successful. The other aspect that I touched on before is secrets management. Here again, the main challenge is how do you deliver the secret to the container that needs it, right? There could be a container that needs, for example, a database password. But only that container should have it, not other containers on the same hosts, not other containers in the same cluster. And you don't want to embed that secret into the container when it's being developed, because then a lot of people in the development environment will have access to it, and you don't know in advance where it's going to run. So it's not a very secure way of doing it. So what we do is we leverage existing enterprise secret stores like HashiCorp Vault or CyberArk or others provided by the cloud providers, and we map the secrets to the containers that need them and then inject them securely in encrypted manner in memory to the container in runtime. And this enables you also to see where those secrets are and rotate secrets, just like you rotate passwords, or revoke them with no downtime at all to the containers. The next stage is really applying the runtime profiles. Here we use machine learning to profile the container behavior, typically in the testing stage. And we basically look at various aspects of the container operation, including what executables it runs, processes, user namespace volumes, etc. Really tightens your environment in terms of security, and even things like zero-day attacks, attacks that you don't know in advance what shape they will take. We're not looking for a signature or malware or anything like that. We're just looking at the behavior. And if the behavior starts looking weird, then we know it's an attack. As I mentioned before, there's also a container firewall aspect. So here we visually map the network connectivity of containers. We do this it's automated. And we profile and give you basically a list of the types of connections or the exact connections we see, whether it's through external IPs or between containers or applications. And we allow you to create or immediately turn those into firewall rules that really, again, determine the scope of network connections that are allowed within this application. And we can alert or block on other connections that we see that are not considered legitimate. And lastly, of course, all of this information is collected into reports, things like benchmarks on your Docker and Kubernetes environments, full audit trail of events, whether it's user logins or container run stop events, policy violations. And we integrate with third-party tools like Splunk or other security event management tools, which typically security teams will use to get a centralized view of everything and be able to analyze logs and run forensics. So to sum up the benefits, what we're really enabling is the automation of DevSecOps, right? The ability to embed security into the DevOps process from early stages of development all the way to runtime. really modernize the way you do security through containers, really. We leverage the inherent capabilities of containers to make the application more secure. And finally, and this is something that that Gu touched on as well, the ability to address different runtime environments, different deployment scenarios, whether it's cloud or on-prem or a combination of both. So you really apply this layer, the security layer, once, and you can run it anywhere. Just to see how it all comes together. So this is a top 10 software company, a name we all know. I just can't use it, but we all know and use their products. They have a corporate-wide container initiative across many business units to basically use containers to enable them to work in hybrid cloud environments. There's already more than 170 application teams on board, with hundreds more expected to get on board. And they selected us as their security layer for the entire stack. And they use us for all the things that I mentioned before. Basically, they use the full gamut of our features. But really, it enables them to accelerate container adoption with no compromise on security, enables them to secure once, but deploy anywhere. I mean, they're already running on both Amazon and Azure as well as on-prem. And also enable regulatory compliance. There was lots of PCI and Sarbanes-Oxley stuff in there. So that's something that we also help them with. And if you need more information, you're welcome to go on our website. And we also have a container wiki where you can learn about containers, various topics, not only security.
Ronnie, thanks for telling us about Aqua Security's solution for containers. There was actually a couple of questions that came in while you were going through your section. The first was, how is patch compatibility tested prior to the development / deployment process?
Okay. So typically what happens is, it depends on, I don't know how early in the process this relates to, but we don't replace things like static code analysis or things that pertain to the specific code that you write. This should still happen. When new images are created, they're often what is changed is not necessarily the custom code that was written, but packages that were collected or updated from public open source software, right? So, and here we simply run it again, and we can see whether this solved, previous vulnerabilities, for example, or whether it introduced new ones. So typically, this is how it would work. I mean, you would simply update your images, or rather create new images, replace the old ones in your pipeline, and we would ensure that they are compatible with your policy.
The second question is, where is the ML processing taking place? Is that in Aqua's own containers, separate from the containers that you are securing?
Yes, it's actually not even there. I mean, our container monitors activity, sends it back to our server, which is also a container, but it can run anywhere, control plane, and we analyze it there. So it takes anywhere from a few minutes to a few hours, depending on what it is you're running.
Great, thanks. I'm going to pass the ball over to Bala now, who will tell us about Big Switch's cloud-native networking solutions for containers. As a reminder, all of the resources that you're seeing in this webinar will be at the end of the presentation. There'll be a link, resources page that links to all of these documents. Bala?
Thank you. Thank you, Ronnie and Gu, for that great overview of your solutions. Let's now turn to the topic of container networking and see how Big Switch's Big Cloud Fabric has been proven to be an ideal SDN Fabric solution for container deployment. But let me first start with an overview of Big Switch Networks. Our company mission is to disrupt the status quo of networking with next generation technologies. We do this in two areas: next generation data center switching and next generation data center security and monitoring. In switching, we do this with a data center switching fabric called as Big Cloud Fabric, which leverages SDN to really simplify data center networking. BCF is ideal for VMware SDDC, OpenStack, hyperconverged systems, and container use cases. In monitoring, we have Big Monitoring Fabric, which leverages SDN to offer pervasive data center visibility for security and performance monitoring, and DMZ security service chaining and cloud monitoring. Now, across both these products, we leverage core hyperscale inspired principles: SDN controller software, open networking hardware, and scale-out fabric architecture. Now, Big Switch has been named a visionary in the most recent Gartner Magic Quadrant for data center networking. If you look at the bottom right visionary quadrant, all the vendors in it are either software-defined or they leverage open networking. This is a testament to our strategy, execution, and the traction we are seeing for these technologies and for our products in the marketplace. Let's start by looking at how application architectures are evolving and what kind of changes they impose to the infrastructure. Traditional applications, as Gu pointed out earlier, they run on monolithic and static infrastructure, which lack agility and are difficult to scale as the business needs grow. Now, the evolving application architectures are demanding that compute, network, storage resources are automatically provisioned and auto-scaled as they grow. Application portability is increasingly a requirement as workloads are dynamically shifted from private to public clouds. Business velocity is an imperative for organizations to stay competitive. And so speed of application deployment and provisioning becomes very critical. So all of this needs to be achieved with a flat budget, and hence customers are looking for solutions with the lowest TCO. In other words, speed is the fundamental underlying necessity today in the data centers. So speed driven by automation, simplicity of operations, rapid change management, and ease of troubleshooting. Now, if you look at it from the application point of view, container-based workloads have evolved to make the deployment more agile, as they are lightweight, easily packaged, and designed to run anywhere, making them portable across different environments. Now, let's look at some of the networking requirements when deploying containers. Typical networking constructs apply: a physical network, which connects the servers running container applications, and which also connect to the external environment. That is what we call as east-west and north-south traffic. The virtual network, which resides inside the server host, and additionally, the typical services such as security and load balancing. Now, as containers are rapidly spun up or down, the networks need to adapt to that same rate of change. So what is really needed is zero-touch automation to enable networking to be dynamic and to move at the speed of apps. Also, when troubleshooting issues in such a dynamic environment, you will need a way to rapidly identify if an issue is with a physical or virtual network or with the containers or applications. Hence, having complete visibility of the environment and the traffic flow between container endpoints is key for rapid resolution of issues. Application teams need an application-driven logical model for networking, a uniform model that applies across VMs, containers, and bare metal apps. In addition, service insertion mechanisms are needed as well. So traditional box-by-box networking approach is just cumbersome and ineffective to achieve the speed needed for the deployment of container-based applications. We'll soon see why Big Cloud Fabric, or BCF, as I call it in short, is the ideal SDN fabric for container deployments in production environments. But before that, let's look at the two popular networking models that are adopted by enterprises today. The overlay-underlay model, so where the overlay is the network of virtual switches leveraging an encapsulation or tunneling technology like VXLAN run on top of a physical underlay network, which does pure IP-based forwarding. The other model is a network that unifies the physical and virtual networks provisioned and managed, operating as a single logical entity. Now, Big Cloud Fabric can be an effective networking solution with either of these approaches. In the physical-only approach, BCF brings all the benefits of automation and visibility to the physical network. In the unified physical plus virtual approach, these same benefits are extended to the virtual layer as well, and the control and management of both layers are unified. Now let's take a look at the solution and see why Big Cloud Fabric is ideal SDN fabric for container networking. The physical network is a leaf-spine class fabric of open networking switches managed by central SDN-based, a pair of central SDN-based BCF controllers. A solution offers a vendor choice of open networking switches. So today we support Dell EMC, HPE, and Acton open networking switches for building the physical network. Now for the unified physical plus virtual fabric, the SDN controls are extended to the virtual switches. The virtual switches are essentially user space agents running on top of OVS, which are running on the host. Now, if you look at the fabric itself, there are no complex protocols that are run, and the centralized SDN controller acts as a single point of control and single pane of glass to manage the entire network environment. The BCF controller also acts as a single point of integration with container orchestration systems such as Mesosphere, Kubernetes, Red Hat OpenShift, and so on. The container network automation happens with an agent that runs on the controller and a CNI-based or libnetwork container plugin that runs on the host. So when a container is spawned, the networking for it is automatically taken care of across the network infrastructure, which is under the domain of the controller. As we talked about earlier, given the dynamic nature of container deployments, this dramatic simplification of network operations is very essential to achieve the speed. Visibility is a very important benefit that we get with this approach, as the network admins get a view of all container endpoints, and troubleshooting becomes extremely simple with end-to-end path visibility from one container to another. So the entire experience that application teams desire to provision and manage networks at the speed of containers can now be achieved with the Big Cloud Fabric container solution. Now let's look at some of the container network automation workflows that we have with Big Cloud Fabric. When hosts running containers are connected to the leaf switches of the BCF, they are automatically detected and admitted into the fabric. There's no need to configure any link aggregation groups for this. And this way, the entire fabric is stood up in a zero-touch fashion, which again makes it a very scale-out and agile model. In addition, the BCF dashboards show that the host is part of the appropriate interface group of the fabric. Next, when a new container is created, it is automatically added to the corresponding layer 2 network. And if one does not exist, the network segment is automatically created. The BCF controller also provides visibility into container endpoints that are dynamically learned via the container orchestration system that it integrates with. So the details such as container name, description, tenant, segment, network constructs such as IP, MAC, vSwitch, and so on. Now let's turn to some of the visibility benefits. Specifically on troubleshooting, Big Cloud Fabric provides a valuable fabric trace feature for troubleshooting. With this, the network admins can do a connectivity test between any two container endpoints with just a few clicks on the controller. Once you provide the container endpoints, an end-to-end fabric view of the path is provided by the GUI from the source container, vSwitch, leaf, spine, destination, leaf, destination, vSwitch, destination container. This is only possible because the Big Cloud Fabric controller manages and has visibility into both physical and virtual networks from a single pane of glass. And it provides excellent operational savings as it completely eliminates complex box-by-box CLI hopping and hence avoids the painful troubleshooting experience as is typically seen with traditional networks. Now, BCF provides analytics dashboard, which has historic report of all events, statistics, as well as customized information related to container networking. The dashboard has a graphical view of all container events. You can zoom into specific historic time windows to get event details corresponding to that time window. More individual event details can be found for specific events from this dashboard. Now, I'd now like to talk about a customer deployment of a Big Cloud Fabric container networking solution. The customer is Neo, the same customer which Gu talked about, which uses Portworks as a storage solution as well. Now, Neo is a high-performance electric vehicle manufacturer that's leveraging containers to build out a scale-out platform for the large amount of IoT data that is needed to be processed from their autonomous electric vehicles. Now, Neo has picked BCF with Dell EMC switches as their container networking solution. BCF's integration with multiple container orchestration systems is providing them great flexibility and is being seen as a huge advantage for their deployments. Now, as you can see from the customer quotes, they've really benefited from the simplicity of the BCF solution and have realized significant reduction of network administrative costs as well as CapEx in comparison to traditional networking solutions. The automation and visibility benefits have really enabled them to achieve the agility and speed needed for their large container deployment. BCF has gone through a journey in the past few years to enable rapid deployment of applications across a variety of workloads and different types of infrastructure environments. The journey started with being the ideal SDN Fabric for OpenStack in 2015, a use case that large telcos like Verizon have been able to leverage for their large NFV deployments. In 2016, the BCF integration with the VMware ecosystem of products, including vSphere, NSX, vSAN, has enabled enterprises to realize all the great automation and visibility benefits for their VMware environment. And in 2017, BCF extended industry leadership into networking for cloud-native applications with the launch and successful deployments of BCF container networking and integration into multiple container orchestration systems, such as Kubernetes, Red Hat, OpenShift, Mesosphere. Now, coming into 2018, BCF integration with HCI systems such as Nutanix and Dell EMC Scale.io has been announced, and we already see customers deploying these solutions as well. With the flexibility and automation provided by the BCF architecture, customers now have the freedom to innovate, freedom to run their networks at the speed of applications, freedom to reduce complexity with deep telemetry and visibility, and freedom to be free from the shackles of proprietary vendor lock-in. All in all, the ability to do networking at the speed of virtualization and cloud. Now, finally, I wanted to point out a unique benefit that Big Cloud Fabric offers, a concept called vPod. BCF integration allows working with multiple orchestration systems in parallel. vPod is a logical entity which can span across multiple racks and is managed by an orchestration system. A single BCF can support multiple vPods with different container orchestration systems and also OpenStack VMware environments. Compute nodes can be repurposed to different vPods on demand, and overlapping IPs and VLAN tags can be used across vPods. So with this, one does not need to build a separate fabric for each application and can greatly help reduce management and operational overhead. So with that, I will turn it over to you, Kate. Thank you.
Thanks, Bala. That was a great overview of Big Cloud Fabric. There's a few more questions that came in. Before we do that, I do want to remind everyone that you are able to ask questions or provide comments for our panel through the questions tab on the webinar dashboard. So if you do have questions, please send them in now and we'll go through them with the remaining time we have for today's webinar. Bala, we received a question for you. Is the API for the BCF analytics exposed and capable of exporting that data, or do you have to rely on logs?
BCF Analytics dashboard. So today we have the BCF Analytics dashboard, yes, and we have, as far as I know, those are can be exported through REST APIs, and we can definitely confirm that and get back to the person. But I think we do export a lot of the details, and it can also feed into systems, log systems like Splunk, logging systems like Splunk, and so on.
Great, thanks. Gu, we received another question for you. Can you explain the relationship between container security and DevSecOps?
Container security and DevSecOps. So I'd suspect that that's probably a little bit more of a question for Ronnie here, but I can give you my take on it from a storage standpoint. Where Portworx gets involved with security is really around content security, and it falls in two buckets, and I hope this is probably what the asker was asking, but we handle volume security through encryption. So we support integration with the key management software like HashiCorp's Vault and so on, and so we do the encryption before the data even hits the wire, so your volumes are encrypted throughout its life cycle as you back them up and as you move them across clouds. And the second area where we get involved is around ACLing. So we adhere to user groups and ACLs to enforce who has access to which volume. But I'll probably let Ronnie answer some of the DevSecOps related questions.
Sure, I'd be happy to. So, the way we look at it is that, where and how you apply the controls is important, right? If you're running a process, a DevOps process, where you're having very rapid cycles of development and deployment, you can't simply wait for things to be deployed and then apply whatever security measures you think of applying there. It's just not going to work. And so what we do is enable teams, DevOps teams, typically they are teams, to each contribute to security in the way that is the most effective for their role within the team. So developers have visibility into the vulnerability posture and security posture of the code that they're creating, and they can also get some remediation advice and basically fix it right there and then. So it doesn't even get to security. The security teams are the ones who set the policy and say, okay, I'm not going to run anything in my environment that has a vulnerability score, a severity score of more than 4. That's also, for example, a PCI requirement. Or there are certain blacklisted vulnerabilities that I would never run. Very dangerous ones like Heartbleed. I would, I will enforce, for example, that containers only run without root user privileges, those sort of things. So we tie the knot basically between the people who create and enforce the policy and also need to make sure that it's enforced, to the people who can actually implement this in the most efficient way, which is more often than not the developers.
Great, thanks. Another question that we received: does Portworx support erasure coding, and if not, is that planned? So you might be on mute if you're speaking.
Sorry, yeah. Portworx currently does do a form of erasure coding. So the way in which Portworx's data distribution works is it favors hyperconvergence, actually. So strict erasure coding breaks some of the hyperconvergence rules. So we are data-wise efficient. Data is deduped. So there is efficiency in how the replicated data is stored. But Portworx is more closer to a hyperconverged solution than a completely dispersing the blocks across various nodes in the cluster. So yes, data is replicated, data is deduped. We also support inline compression, but we prefer the hyperconvergence model as opposed to strictly striping the data across different nodes in the cluster. Hopefully that helps.
Thanks so much to all of our panelists today. This was a great webinar. For the attendees, if you would like any additional information on any of the presenters or the companies that they were speaking about, you can go to their websites. Portworx is http://portworx, portworx.com. Aqua Security, http://AQUASEC, aquasec.com. And Big Switch's website is http://bigswitch.com, and you can find additional information there. There are a couple of questions left in the queue. We will address those individually. You can expect a response over email from us. We make it easy for you to get started with Big Switch solutions. There are several resources you can download or watch that will give a tour of our products. In your handouts, you will find 5 links you can click to access any of these resources listed here, as well as resources from our panel. With BSN Labs, you can experience Big Switch Network's bare metal SDN solutions firsthand from the comfort of your PC. We believe that there is no better way to learn about a product or technology than to take it for a test drive. For a free online real-time access to our SDN Fabric products, please visit labs.bigswitch.com or download the handout. Please join us on Wednesday, March 28th for our next webinar, OCP Summit Recap, Open Source Networking with Facebook, Google, and Big Switch. The following webinar on Wednesday, April 4th is with Storage Switzerland on HCI networking. Watch your email for registration details or check our website webinar catalog. Thank you to everyone for attending today's webinar, and thank you to our panelists, Ronnie, Gu, Bala.
Thank you for having us.
Thank you.
That concludes our presentation for today. Thank you for joining us.